Today we'll talk about truth functional analysis. This is the process of determining the truth value of a complex sentence from the truth values of the component sentences. This is possible because the connectives that propositional logic works with are truth functional. What does this mean? A connective is truth functional just in case it forms sentences with the following characteristic: that the value of the complex sentence depends exclusively on the truth value of the components. This can be seen in the case of the conjunction. For each combination of truth values of the components, there is one and only one value for the complete sentence. For instance, if Al plays is true and Beth works is false, then the value of Al plays and Beth works is fixed. It has to be false. And if Al plays is true and Beth works is true, then Al plays and Beth works is true. It can't take any other value. However, we also have non-truth functional connectives in English, such as because. Suppose that we have the sentence, Al plays because Beth works. Even if we know that Al plays is true and Beth works is true, just on the basis of that information, we can't determine whether the sentence Al plays because Beth works is true. It may be that Al plays and Beth works, and that Al plays because Beth works because, say, Beth is the only source of income in their household. Or it may be that Al plays and Beth works, while at the same time it's false that Al plays because Beth works, because those two are completely independent facts. Thus, in the case of sentences formed with because, the truth value of the whole doesn't depend exclusively on the values of the components, since there are additional considerations to take into account. So, because is not a truth functional connective, and that's why prepositional logic works with connectives such as and or, which are truth functional, but not with, say, because. So again, because, while, believes, and others are non-truth functional connectives, because in these cases, the value of the complex preposition does not depend exclusively on the truth value of the component sentences. In contrast, for truth functional sentences, that is, those formed with and, or, not, well, once you fix the truth values of the simple sentences, then taking into account the kind of connective we're working with, then you automatically fix the truth value of the complex sentence. Let's do an example. Suppose that A, B, C, and D are prepositions or statements, and that they have the following values. A is true, B is true, C is false, and D is false. So, are we in a position to determine the truth value of prepositions 1 to 4? Yes. That is because the truth values of those prepositions depend exclusively on two things. First, the truth value of the components, and second, on the way in which the components are put together, that is, the connective being used. And all the connectives that appear here, that is, the ampersand, the V, and the tilde, are truth functional. So we said that the truth value of the whole depends on two kinds of elements. One is the truth values of the components, and second, the way in which they're put together, that is, the connective being used. And so these two components are represented in these two tables. The first one, the topmost one, is the values of the component sentence, in the case A and B. And the second one is the truth value for the conjunction, right? Because that is the relevant truth table in the case of the first sentence, A ampersand B. And the truth values of the atomic sentences that are going to be important for us are going to be the truth value for A and for B. So just by looking at the table at the top, we know that A is true and B is true. We also know that A and B are joined by the ampersand. So the relevant truth table is going to be the truth table of the ampersand to our left. And the truth table confirms that when you have one conjunct being true and the other conjunct also being true, and they are joined with the ampersand, the result of the whole is going to be true. And we can see that the relevant case is the first row. So A ampersand B is true. And what about A ampersand C? So we have ready the truth table for A ampersand C. We can tell that A is true and C is false. And so what do we get when they are joined by the ampersand? Well, if we look at the second row, we see that the truth value that corresponds is false. And that's what we write down, false. So sentence 2 is false. What about sentence 3? The relevant sentences are B and C. And the relevant truth table is that for the B, or disjunction. We can see that B is true and C is false. And we can see also in the second row of the truth table for the B that when one of the disjuncts is true and the other one is false, then we get true. And that's the truth value for B or C. Our next sentence is not C and D. This sentence is formed by joining C and D with the ampersand and then applying the tilde or negation to the result. So we can see that C is false and that D is false. And that in the truth table of the ampersand yields false, right? So you can see the result here in the fourth row. Our case corresponds to the fourth row, in which both conjuncts are false. And so how do we determine the value of not C and D? So what does the negation do? Well, what it does is simply to invert the value of the sentence that is being negated. In this case, C and D was false, and so when we add the tilde, we get truth. So not C and D is true. Okay, that's all for now.